Okay, I just want to focus on 6 and 7. I don't think I might briefly talk about the next few as well. So 6, this equation is actually a very important equation. We don't need to know much about it now, but I will mention it. It's called the difference of two squares. So and we don't need to know much about it right now, apart from the interesting property of it. Point is, let me just get my highlighter out. We've got this. This term is the same in both brackets, and this term is the same in both brackets, but we've got a minus and then we've got a plus. So in other words, the difference of two squares is always going to be something, which I'm going to call A, minus something else, which I'll call B, all of that being multiplied by the same something plus the other same something, but we have to have a minus and a plus. Okay, and what we end up with, as we can see here, we've got the x, so this multiplied by that, so let's like a times a is a squared, and then we have this times that, which gives negative. Well, so you did okay, yeah. That times that, which gives so ab. So we got plus ab, and then we've got. I'll highlight all this more carefully in a moment. And you got negative 3 times x. That gave, in this case, now b. I could write negative ba, but that's the same as saying negative ab. And then I've got minus b times minus b, so that's going to be, times plus b, which is minus b squared. Now, all the time, let's just, I'm just going to highlight some of these terms so we can see what's similar. So there's the first term. And then here's the second term. And that's the same term again, but one's a plus and one's a minus. And then we've got the final term there. So these two terms, when we do this kind of equation, they always cancel out. We have an a squared minus b squared. This is why it's called the difference of two squares. When we're working out the difference of two numbers, we minus them. And these are square numbers, and so that's why we call them difference of two squares. It's a clever tool which you can use to solve more complicated equations. But for now, we'll just be familiar with it. And when you get really good at this, you can start to skip all of that because you'll know straight away, oh, it's going to be x squared minus 9. The other one I want to talk about is this one here. I should emphasize, you don't need to know, for the moment, you don't need to know anything about difference of two squares. We are going to be coming across it later on. I just wanted to mention it so it'll be less of a surprise when we do it later on. But we just expand it and then just notice, oh look, the middle stuff disappeared. Now this one looks a bit confusing and can catch people out when they first see it, but it just means, just like x squared means x times x, 3 squared means 3 times 3, this means x minus 7 multiplied by x minus 7. And then you just treat it the same way you would treat any other expansion. In these next few 8 to 12, we are expanding. It's just the end difference will be is that the first term won't be like x squared or y squared, but because you're going to multiply 2y by y. So just take care to think about how that's going to be 4x by 3x and so on. And later on, we're combining those kind of things. And again, we've got this square thing. And just remember to write out 2x plus 5 multiplied by 2x plus 5. So I don't think... And then once we got to question 15, We have to apply our understanding to situations. So just I just thought I'd put that little warning video up. So if you get stuck on the next few questions, you can watch this video to kind of help you out with how to do that. Okay.